students. Today we'll begin with a new chapter and the name of chapter is circles. In fact, it's a hot sum, question number 9. Hot mind sum for Maharashtra State Board. Given to us, there is a circle. In this circle, there is a triangle inside. Name of the triangle is ABC. There is a chord DE also. There is a chord DE which is intersecting side AB and AC at point P and Q with some conditions. These conditions are arc AD, arc DB congruent. Arc AD and arc DB is congruent. So arc AD is congruent to arc DB. These two arcs are congruent. Arc AE, arc EC congruent. These two arcs are also congruent. So given part, triangle ABC. Then after an arc AD, this is also known, congruent to arc DB, arc AE, congruent to arc EC. We need to prove angle PQC congruent to angle BPQ. Before going ahead, students, I want to tell you, though this sum is in HOTS, this is one of the most easiest sum which I have come across. Just 2 steps are there to get the answer. Now, it looks astonishing difficult, but just 2 steps. There are only 2 steps which you require. There are only 2 concepts which you are going to use, and you can score 5 out of 5 marks. Only thing you need to do is understand it, do once practice, second time do it yourself, third time ultimately do it without any help, and forever you will remember this sum. This is my bet to you, this is my guarantee to you. So we'll start with this sum now. Now, if you go back to theorems, we already know circle, 2 chords intersecting inside, angle formed is half sum of intercepted arc, right? जो angle form होता है वो होता है half sum of intercepted arcs. Intercepted arc, which 2 arc? Arc intercepted by the angle and the arc intercepted by vertically opposite angle, right? Same thing, we require angle PQC and angle BPQ. This is our angle PQC. So first I'll take this angle, right? Angle PQC. So with angle PQC, we'll take angle CQE. We'll take this angle. Now if you look at this angle, which I have marked now, you can make out this is one angle formed interior of circle. So this angle will have relation with these 2 arcs. Same way, angle which forms linear pair with angle BPQ. This is your angle BPQ. Angle which forms linear pair with angle BPQ is this angle, right? So we'll make use of these 2 angles now. So I'll write it down. Chord AC, AC and BE intersect interior of circle at point Q. Therefore, at point Q, chord AC and chord DE intersect circle interior at point Q. Therefore, angle CQE is equal to half sum of intercepted arcs. We have done this theorem. Therefore, angle CQE is equal to half. Now, intercepted arcs are arc EC and arc AD, half measure arc EC plus measure arc AD. So you got angle CQE as half measure of arc EC plus measure arc DE. This is our first equation. Same way, if you look at, this is the second angle chord AB, chord DE, chord AB and chord DE intersect interior of circle at point, which point? At point P. Therefore, angle BPD is equal to half sum of intercepted arc therefore angle BPD equals to half. Now intercepted arcs are these two arcs, that is arc DB plus measure arc AE. Second equation, right? So we have obtained angle AQE relation with the arc, we have obtained angle BPD relation with the arc, right? So far we have established these two relations. Now look at first and second nicely. I mean, look at first equation statement, second statement equation. You will come to the conclusion in first equation, right hand side we have half arc EC, arc AD. Second equation, right hand side we have got arc AE, arc DB. Also known to us, relation between arc EC, arc AE, arc AD, arc DB. So I take one more equation now. Also arc AD congruent to arc DB, arc AE congruent to arc EC. This is combined. Suppose I take third equation, this is given to us. Now what is third equation doing now? Third equation is helping us to identify that right hand side of first equation, right hand side of second equation are same. Arc EC congruent to arc AE. So these two parts equal. Arc AD congruent to arc DB. These two parts equal. Result is entire right hand side of first equation, entire right hand side of second equation are equal. Result is angle CQE congruent to angle BPD. How we got this? 1, 2 and 3. So these two angles are equal now. Which two angles? Angle CQD, angle CQE and angle BPD. Angles are equal. Also, we are very close to the answer now. Angle CQE plus, there is one more angle, that is angle PQC is equal to 180 degree. Reason is linear pair. Same way, angle BPD plus the other angle is BPQ. Can you make out? Angle BPD plus angle BPQ makes 180 degree. Reason is same, linear pair. Now this is our fourth equation. This is our fifth equation. These are sixth equation. Now fifth and sixth, right hand sides each 180 degree. Equation number 5, right hand side is 180. Equation number 6, right hand side is 180. That means left hand sides are equal. Therefore, we can say that angle CQE plus angle PQC equals to angle BPD plus angle BPQ. This we got from equation number 5 and 6. And we name this equation as seventh equation. Now we need to look at equation number 4 and equation number 7. Equation number 4 says that angle CQE congruent to angle BPD. Equation number 7 says that angle CQE is on the left hand side, angle BPD on the right hand side. BPQ is on the right hand side. The result is we can eliminate these two terms. Why? Because CQE is congruent to BPD. So we can eliminate CQD and BPD. What remains? Angle PQC congruent to angle. Which angle? Angle PQC is congruent to angle BPQ. Why BPQ? Because this term we have eliminated. BPD and if you look at BPD angle congruent to angle CQE. So these two terms are eliminated. What remains? Angle PQC is equal to angle BPQ. The same thing, right? Though it looks bit lengthy, though it involves lots of writing, but concept applied is only angle formed interior of circle. When angle is formed interior of circle, result is half sum of intercepted arc. Twice we have used this marked angle, marked angle. These two arcs, but these arcs are congruent. Result is angles are congruent. If these two angles are congruent, angles supplementary to those angles are also congruent. Right? When two angles are congruent, angles which are supplementary to those angles are also congruent. Take one example. 70 degree. Name the angle which is supplement to angle 70 degree. Answer is 110. Right? Now, if one of the angle is 70, other angle also 70. This supplementary angle of 70, both time we are getting answer as 110 only. That is why I said when we got these two angles equal, angles which are supplementary to those two angles will also be equal. That is what we want. If these two angles congruent, angle PQC supplementary to this angle, angle BPQ supplementary to this angle. As these two equal, so these two are also equal.
No more spending your energy and money on coaching classes or missing classes for rain, for rally and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Question number 10, problem set. Sorry, again it's hot. Question number 10. So we'll start with 10, sir. Question is, in triangle ABC, angle A is an obtuse. Angle A is obtuse. When we say obtuse, should be more than 90 degree. Angle A is obtuse. Then after that, P is circumcenter of triangle ABC. Point P. Circumcenter of triangle ABC. To prove angle PBC is equal to angle A minus 90 degree. That's it. This is the question. But this is in hot section. First, you need to know how to draw the figure. So triangle ABC, angle A is obtuse angle, point P is circumcenter of triangle ABC. इसका मतलब हमको दिया हुआ है एंगल A obtuse है और एक सर्कल है जिसका सर्कमसेंटर P है. अगेन एंगल A obtuse है, एक सर्कल भी है. सर्कल वो सर्कल होता है जो ट्राइंगल पे बना हुआ है, राइट, सर्कल, और उस सर्कल का सेंटर है P. So to ease out things, मैंने सर्कल से स्टार्ट किया. एक ट्राइंगल है जिसमें एंगल A ऑब्ट्यूज है, इंपॉर्टेंट पॉइंट, एंगल A ऑब्ट्यूज है. रिमेनिंग नेम्स BC. सो ट्राइंगल ABC ड्रॉ हो गया. सेकेंड पॉइंट गिवन, P जो है सर्कमसेंटर है. दिस वी नीड टू प्रूव. सो गिवन angle A, obtuse angle, P center, I'll write circumcenter only to prove angle PBC is equal to angle A minus 90 degree. Again students, two steps are involved. You need to know how to apply those two steps. एक हम लोग यूज करेंगे सेमी सर्कल प्रॉपर्टी. एक सेमी सर्कल प्रॉपर्टी हम लोग यूज करने वाले हैं. हिंट आई हैव ऑलरेडी गिवन यू. सो कीप वॉचिंग व्हाट वी आर डूइंग नेक्स्ट. सो व्हाट आई एम डूइंग इज, एज वी रिक्वायर एंगल PBC, सो आई एम जॉइनिंग BP प्लस आई एम एक्सटेंडिंग दिस so that this line meets circle, say at point Q. Right, at point Q. Also, I am joining CQ. So construction, draw BQ passing through center P, join CQ. So two construction I have done, straight line drawn, this line joined. We need to get answer angle PBC is equal to angle A. That means relation between these two. We need to get relation between these two. Clear? So we'll start with the proof now. Now you can make out angle A. If I join this line also, angle A is 90 degree plus of this angle, right? Angle A will be 90 degree plus of this angle, right? So I am joining AQ also. As I said, BQ is a diameter, this angle will be 90 degree. And these two parts will be equal. So I am writing now. Angle PBC angle QAC inscribed in a same arc. These two angles are inscribed in a same arc. These two angles are inscribed in a same arc. This is the same arc. Which arc? This is the arc. Now in this arc there is one angle, there is second angle. Now we know when two angles are inscribed in a same arc, angles are congruent. Therefore, we can write angle QAC is equal to angle PBC. First equation. Angles inscribed in a same arc are congruent. Angles inscribed in a same arc are congruent. Now, look at angle A. Angle A is a part of two angles, that is angle BAQ and angle QAC. But before that, we'll write BQ diameter. Why BQ is a diameter? Because P is the center and BQ is passing through center P. Therefore, angle BAQ is equal to 90 degree. Reason, angle in a semicircle. Angle in a semicircle is right angle. Second equation. Now, angle A is equal to, now this full is angle A. This angle A is equal to angle BAQ plus angle QAC. Reason is angle addition property. We can add two angles, like how we can add two numbers. Angle addition property. These are equation number 3. So far what we have done is angles inscribed in a same arc are congruent. We have applied diameter property which says angle formed by a diameter is right angle at any point on a circle. Then we have applied property of angle addition. Now from these three equations, this QAC from 1 can be written as PBC and this BAQ can be written as 90 degree. Therefore result is angle A is equal to 90 degree plus angle PBC. This is from first, second, third. Don't you think we are almost at the answer? जो हम लोग हैं ऑलमोस्ट हम लोग आंसर में आ गए हैं, बस थोड़ा सा एक स्टेप रह गया है. And that step is we just have to bring 90 degree on other side equals to angle PBC on right hand side. 90 I am taking this side, so this becomes angle A minus 90 degree. Drawing a figure. After that, applying just theorems which are required. Next thoughts, question number 12. Given to us, triangle ABC is an equilateral triangle. Then given to us, bisector of angle B intersect. So first I'll draw the figure only so that we can write the given part accordingly. So given to us, triangle ABC is an equilateral triangle. So I've drawn triangle ABC. Then BP is bisecting angle B. So name of the triangle is ABC. And this point is P. Now next what's happening is, from here we are drawing a line which is intersecting this line at point. This is how the question is. This is your point Q. Triangle ABC equilateral triangle. BP angle bisector. BP is angle bisector of angle B. To prove CQ is equal to CA. Again, triangle ABC is an equilateral triangle. All three sides are equal. BP is an angle bisector. These two angles are equal. And this is how figure is drawn. We need to prove CQ is equal to CA. So we'll start with the proof of this. Triangle ABC equilateral given. Therefore, all three angles will be 60 degree because in equilateral triangle sum of three angles is 60. Sum of three angles is 180 and all three angles are same. Therefore, we can say that angle A is equal to angle B is equal to angle C. Therefore, we can say that angle A congruent to angle B congruent to angle C congruent to 60 degree. Now equilateral triangle, all angles are 60 degree. So we got all three 60. Now, BP is an angle bisector of angle B given. Therefore, we can say that angle CBP is equal to half of angle B. Therefore, angle CBP is equal to half of 60 degree. Therefore, angle CBP is equal to 30 degree. So, angle CBP is 30 degree. Now, CBP angle and angle CAP has to be same because both angles are inscribed in the same arc. Angle CBP, angle CAP are inscribed in a same arc. Therefore, angle CBP is equal to angle CAP. Therefore, angle CAP also 30 degree. So we got angle CAP as 30 degree, first equation. So as of now, this angle is 30, we got. Also, angle C, we are calling this as angle C, plus angle ACQ is equal to 180 degree. We can make out it's a linear pair, so sum has to be 180 degree. Therefore, C is 60 degree. 60 degree plus angle ACQ is equal to 180 degree. Therefore, angle ACQ is equal to 180 degree minus 60 degree. Angle ACQ is equal to 120 degree. Second equation. Also, in triangle ACQ, sum of three angles has to be 180 degree. We can write in triangle ACQ, angle CAP plus angle ACQ plus angle Q is equal to 180 degree. As I said, sum of three angles of a triangle is 180 degree. So now CAP is 30 degree from 1, ACQ is 120 degree from 2, plus angle Q is equal to 180 degree. 150 degree plus angle Q is equal to 180 degree. Angle Q becomes 180 minus 150, that is 30 degree. Equation number 3. Now, from 1 and 3, we can say, therefore, angle CAP is equal to angle Q from 1 and 3, both are 30 degree. First equation says that angle CAP is 30 degree. Third equation says that angle Q is 30 degree. This means that angle CAP or call it angle CAQ, whatever, angle CAP is 30 degree, angle Q is 30 degree. Therefore, we can say that CQ is equal to CA. Reason? Sides opposite to congruent angles. When two angles are congruent, sides which are opposite to angles are also congruent. Therefore, we got CQ congruent to CA.